So in this video we'll talk about the dimensional analysis. So the things that we will look into these questions. The first question we'll look into: determine whether each of the following equation is dimensionally consistent. Then the other one, we also look into the acceleration of a particle moving with a uniform speed in a circle of a radius r is given by an equation. So that's an equation which is a, then kr to the power n, then v m to the power v. So where k is a proportionality consistent, then the question says determine the values of n and m, and write the simplest form of an equation for the acceleration. So these are the questions that we'll concentrate in this video. So before we go into the questions, the first thing that we need is we need to understand what this dimension analysis is. So before we go into the definition of the dimension analysis, we need first to define what a dimension is. So according to my definition, I defined the dimension in this way: is the physical quantity, is the physical nature of a quantity, e.g. length, mass, time. So that's what we call a what? A dimension. And the symbol used to specify the dimension of length, mass, and time are L, M, and what? T respectively. So meaning that what we'll be looking into dimensions of the what? Of a quantity, which is what? A physical nature. So those are the things that we'll be looking into. So let's define what is the dimensional analysis. So according to my definition, I define it in this way: is the algebraic expression of the dimensions of a physical what? Quantity. So when look into this one, it says what is the algebraic expression of the dimensions of a physical quantity. So meaning that when you talk about the dimension analysis, is an expression that represent the physical what? Quantity. Or in another definition, that is this one, I also defined in this way: a dimensional analysis is the analysis of the relationship between different physical quantities by identifying their base what? Quantities. So you first identify what is the base quantity of the physical quantity. So now that's where we will also look into base quantities and also what we call the fundamental what? Quantities. So before we enter into much detail, we need also to know what are the base what? Quantities, because you can't do anything before you know what are the what? Base quantities, because this dimensional analysis, it expresses the physical what? Quantities. So we need first to know what are the base what? Quantities. So in my notes, I defined like this. So the base quantities that I have so far, the base quantities, the first one is what we call the what? The length. When you look at the symbol of the length, it can be L or capital L, and it is in what? Meters, and the symbol is what? M. But when you take it into the dimensions, so what is the dimension of the length? It's supposed to be represented as what? As L, capital L. and the mass again is the same, which is m, and the name is kilograms. So these are the SI units in short, which is the symbol is what? Kgs. But when you take it into dimensions, it's supposed to be what? M, as like m. And time t here, and SI units are seconds. Then symbol is S, and the dimension is represented by what? By capital T. So meaning that wherever there's time, just know that capital T is the one which is what? Being represented. How about the electric current? The electric current here, it's the symbol is I, and or small I, and the name of SI unit it's ampere, and it's represented by capital A. But when you take it into dimension, it is represented by what? Small letter I. Then again, temperature. So temperature is T, and the SI unit is Kelvin, which is a symbol which is K. And in dimensions, this one is represented as a theta. So this is the theta here that we are seeing here. And the other one is amount of substance, which is X. And which is what? N is the one which represents that. N is the one which represents that. And the SI unit is the mole. And the mole, this is the mole that we are seeing here. And when you take it into dimension, it is N that is represented like capital N. That is the one which is represented. Then the last one is what we call luminous intensity, and this is the symbol, and with the unit SI unit is candela, which is CD, and is represented by J in what? Dimension what? In dimensions. So we need to know the base quantity and what is being represented in a what? In dimensions. So let's go into the other one. So if you look at this one, now we have the physical quantity, which is the volume, right? The volume. The expression, we have the length, in short, or the formula. The formula of the volume of or a box, right, or rectangle, it's length times breadth times what? Height. So if you look at the dimension of the length is what? The dimension of the length is what? Meters, right? Again, this side again it is meters. Again, this side is again it's meters. Now, meters, it is meters cubed, like that, right? So since it's meters cubed, what is the dimension or the symbol that length is being represented? When you check this side, length is represented by what? By capital what? L. And it is what? Meters. So since it's meters, meaning that when you take it into dimension, it will be what? It will be length cubed. That's what it means. If you look at the other one again, it's the same density. So what is the formula of the density? The formula of the density is mass over volume. So mass in dimension, it is represented by what? Since it's the formula of density is mass over volume. What is the representation of the mass in dimension? Remember that it's represented by what? Capital what? M. How about volume? It's L what? Cubed. So this is the one that we are seeing this side. Even velocity is a displacement over time. Displacement, it is measured in meters length, right? So meaning that dimension is what? It's L. What's the time? It's T. How about the acceleration? The acceleration is the same, which is the velocity over time. So meaning that this side where the dimensions, we will just be talking about the base what? Quantities that we learned here. when you look at these ones here, these ones here, they are the ones that will just be what? Taking note of. So that's how we do these ones. Now let's check at the importance of this dimension analysis. We can be talking about the dimension analysis, so we need also to know the importance of this dimensional analysis or the application. This is supposed to be application of what? Dimensional what? Analysis. So the first important or the first application, what does dimensional analysis does is that it converts a physical quantity from one system of units to another. So what does it do? It converts the what? The units from one system into what? Into the another. Then the second one is what? It also checks the dimension, no, correctness of a given what? Equation. So it checks if the equation is correct or if the equation is what? It's wrong. Then the second one, it establishes a relationship between different what? Physical quantities in an what? And an equation. So among the three, we will much concentrate at 2, where we'll be checking the dimension, no, correctness of what? Of a given equation. That is the one that we'll be looking at. So we have these examples that we have here, right? So in these examples, we have the first one, right? We have the first one, which is v equal to u plus acceleration then time. So this is the velocity, this is the velocity, this is the what? Acceleration, and this is the what? Time. So we have the final velocity. So the first one here, it is the final what? Velocity. So the first one here, it is the final velocity in short. Let me even write here, final velocity. Then this one, it is the what we call initial what? Initial velocity. Then this one, it's what we call what? Acceleration. Then this one, it is time. So when you look at this and we're determining whether it is dimension consistent or it is not, right? So before you do anything, we need to check out what kind of the dimensions does velocity have. So velocity, what are the units of velocity? It is meters per second. And when you take meters into dimension, it is what? Length. That's what is represented with, which is L. How about S? It's in seconds, and that is time. So it is represented by what? By T, like that. So meaning that the dimension of velocity, it is L over T. So after you have identified that, that's when now you can what? Proceed and find the correct what? Answer. So now let's do this now. Let's solve it now, right? We have known that the dimension of velocity is what? Length over time equal to, again, this is the initial velocity, meaning it will be length over what? Time, plus, if you look at this one, this is the acceleration. The acceleration, what are the units of the acceleration? It's meters per second what? Squared. Now, what is the dimension of the meters? It's supposed to be length over, what is this one? It's time. So it means supposed to be t, supposed to be what? Squared. So you have t, which is squared, then it will be length over t, then what? Squared, like that. Then this is time, right? Since this is time, it is represented by capital what? T, like that. So what will happen is that we have L over T, then L over T equal to L over T. Now here we have two T's, meaning that when we divide one T and this one here, we're gonna remain with one T. So to be L over what? T, like that. Then from there you have L over T equal to L over T equal to, so let me just write this side so that we can utilize this space, which is this side. So if you look at this side, you have L over T plus L over T, such that when we have L over T, this side equal to, this side it will be 2 L over what? T, meaning that when you look at the number, right, in dimensionally consistent, the number it's a constant. So meaning that what will happen, a number is a constant. Any number, whether it's a 2, it's 4, it's 3, it's a constant. So what you need to know is that that number, it will represent 1. So it will be L over T. Then L over T, this side equal to L over T. Then if you look at this side, the right side and the left side, both of them, they are what? They are equal. So the left side and the right side, both of them, they are what? They are equals. If both of them, they are equal, meaning that your conclusion now, you will say that the equation is what? Dimensionally consistent. But if the right side and the left side, they are not equal, you conclude that the dimensionally is not what? Consistent. So that's what we do in that. Now let's go to the another question again. This question now. Let's look into question 2. So that S, that's the same as the displacement. So I can put it as S or X, it's just the same, it's the displacement. Vt plus 0.5 then A T squared. So there you have X, which is the displacement. So the displacement, it is measured in meters, meaning the dimension is what? It's m. How about the velocity? The velocity, remember, it's L over what? T, like that. Then remember, this is the T, which is this side, so to be capital T, right? Then remember that a number, it is a dimensional what? Constant. So meaning that it's what? 1. That's acceleration, so to be L over what? T squared, like that. Then T what? Squared. Meaning that what will happen is that you have this T will cancel with this T, then you remain with the L plus. T squared will cancel with this T squared, they will divide in short, right? Then we remain with what? With L again. Then we have L equal to 2 what? L. Remember that in dimension, a constant, it's a number, so meaning that it will be what? L is equal to what? There it will put just 1 where there's 2, then you say L. Then you have what? L equal to 1 times L. What's the answer? The answer is L. Then your conclusion will say what? It is consistent. That's what your conclusion is. So that's what you do in that situation. So let's go to question 2. So question 2 or question 3, sorry. Let's go again to question what? 3. So in question 3, we do the same thing. Displacement equal to Vt plus 0.5, then a squared, which is the acceleration, then what? T squared. So what is this is the s, or displacement, the s, right? So to be what? L equal to the dimension of velocity is what? L over t, then t there, plus 0.5, remember that's the 1 short, right? Then there it will be what? L over t squared, then what? T squared, like that, meaning that you have L, we have L, wait, since A here is squared, this A, if you look at this acceleration here, is squared, meaning that you square everything again. So meaning that it will be L over t squared. That's the dimension of acceleration. Now this acceleration is squared, meaning that it will be what? Squared again. So meaning that what will happen, it will be this t and this t will cancel, meaning that we have L over, just L over 1, right? Plus this side, what you know what will happen, to be L squared over t to the power what? 4. Remember that you have t outside, which is squared. Now this t cancel with this, meaning that you have L equal to L plus L squared over t squared. After we have cancelled that, meaning that this equation, or therefore, is not what? Consistent. So that's what you write. So meaning that it's not what? Consistent. Let's go to the other one again. So on the other one, you have question 4 now, right? On question 4, we have what? Displacement equal to Vt plus 0.5, then sine Lt, like that, right? So this is the displacement, so meaning that is just L, because it's an what? Displacement. How about the velocity? L over what? T, then what? T, plus this is a number, it's a constant, and this is also what? A sign. So this, all of this, they were represented by 1, so to be 1. Then this is what? Acceleration again, right? So to be L over t squared. Then you have t this side, meaning this and that, they will go equal to L, plus this t and this t, they'll cancel, you have L over t, just like that, meaning that is not what? Is not consistent. Why is not consistent? Because the right side and the left side, They are not equal. So if they were equal, we could have said that it's what? Consistent. But they are not equal, meaning it's not what? Consistent. So we say it is not dimensionally consistent in that situation. Let's go to question 5 again. So in question 5, let's look at question 5. In question 5, velocity equal to sine at squared over s, like that, right? So velocity, remember it's L over t equal to, so this is sine, that's 1 in short. Then if you look at that, on top here you have acceleration, so we need to be L over t squared times what? T squared, right? Over, this is the s, so that's a displacement, so over what? Over L. Then this t squared and this t squared, they'll cancel, right? We have L over t equal to, there you are remaining with L, then over what? L, meaning again is not dimensionally what? Consistent. That's all. So the main secret, you need just to know what kind of the dimensions does this physical quantity has. That's all. Then let's go to the other question. So the another question, this one again, it says determine whether the equation for the period of the pendulum is dimensionally what? Consistent. So remember that you have t equal to 2 pi, then square root of L over g. So this g is an acceleration here. This g is an acceleration, and this is the what? The length of the bob. This is a number in short, right? That's 2 pi. Then this is what? This is the period, right? Which is time. So period, remember, is represented by L, by t, sorry. Then you put the square root here, right? The length is represented by what? By L, just L, right? Then divide by. The acceleration is represented by what? By meters per second, right? Which is what? Length over t what? Squared, right? So I'll write from this side, meaning that it will be t equal to, right? L times, right? T squared over what? L, meaning that this L and this L, they'll cancel, right? Then from there you remain with it. That's 1 times t squared, like that, right? Meaning this square and this square, they'll cancel, then you remain with t equal to what? Equal to 2 to t. So meaning that you conclude, therefore it is what? Dimensionally consistent. Why is it dimensionally consistent? Because the right side and the left side, they are the what? The same. So you conclude that it's dimensionally what? Consistent. Now let's look into this last question. So in the last question, what are they saying? They are saying that the acceleration of a particle moving with uniform speed which is v in a circle of a radius r, is given by an equation where k is a proportionality constant, right? So in that situation, what do you do? What you do here is that we need to find determine the values of what? N and m, and write the simplest form of what? Of an equation for the acceleration. So what do you do in this situation? What is your A? Your A in this situation is the acceleration, right? So since it's an acceleration, meaning to be what? L over t squared, right? Equal to, remember that k that I've said is a constant. So for now we just put k as what? As 1. Then this is r, that's a radius, right? So the radius, it's meters. So meaning that since it's meters, meaning to be what? It will be the length that will be representing to the power what? N. This is the velocity, right? Since this is the velocity, to be L over t, then to the power m. So you know what will happen? The thing that will happen would be L over t squared equal to, right, L to the power n times this m will multiply with everything that is in brackets. So it will be L to the power m over t to the power m. So if you look into this one, you shall see that you have L to the power n times L to the power m. The bases are the same. What do you do with the powers? We add the powers, right? So it will be L n plus m over t to the power m. So if you look at down or the denominators, you shall see that the bases are the same, and here we're equating, right? Meaning that we can just equate the what? The powers. So to be m is equal to what? To 2. So since you have m equal to 2, you have m equal to what? To 2. Then we can find the value of what? Of n. How do we find the value of n? On top, if you check on the on top there on the numerators, you shall see that you have L equal to L to the power n plus what? M. So meaning that we can equate the powers here. So to be n plus c m to the power equal to what? To 1. So to be n plus m equal to 1. Why are we doing that? Because the bases are the same and the powers, so meaning that we can what? The bases are the same, so this means that we can equate the what? The powers, which is n plus m, then we equate to what? To 1, like that. So what was our m? Our m was 2. So it will be n plus, where there's m you put what? 2 equal to 1. Then n equal to 1 minus what? 2. N is equal to, when you subtract there, it will be negative what? 1, like that. So that's what it means here. So you can say a conclusion now, right? Your conclusion, remember, you're just doing a conclusion. Here there are 2 questions. So you need to just to say m is equal to 2, then n is equal to what? 1. Now, and the other question says write the simplest form of an what? Equation for the acceleration. So in that situation, let me just clean up this side. In that situation, you have that, right? Since you have that, you say A equal to K R. What is N? N is negative 1. Then V, what's M? M is 2. So meaning that A is equal to the R, that's an inverse, right? So to be K V squared over r, like that. So that is the equation, or the simplest form of an equation. So they'll give you marks here, again they'll give you marks there, which sometimes can cost 4 marks, sometimes can cost 2 marks. So that's how you do that. So we can end from here. More question will come. Remember to share, like, subscribe.